730. Root 730 there, if you like that. I should do that, just in case someone in here may like that. Root 730. I just think that takes less writing.
Are you fine with us plugging in the U back, or plug the U back in and solve that way?
So, oh, that's totally fine. So what you're meaning by that is, are you telling me like, in terms of a resubstitution in the end, and putting the x's back? That's how I always did as a student, so I actually agree with you. I never did this. I never did this. You know, when I'm grading papers, I notice a lot of students in this class likes to do this, change the limits of U. Most students, I think, agree with you. They just like, I'll wait, and I'll get down here and I'll put back this. Oh great, did I erase it? Did I erase it? What did I erase?
1 plus 9x to the 4th.
I had it erased, but that's getting resubstituted. Right there, raised to the 3/2, and it was a 0 and 3. And you get the same values. Ooh, a hand went up. That's a serious question. Oh. Anyone okay with that? Nice. Hey, this next question is also about the x-axis. If I didn't want something like this to startle you when you're practicing tonight, or tomorrow, or over the weekend. So, what do you think of this? X equals, here's the curve. It's an x. 1/3, 1/3, parentheses, y squared plus 2 to the 3/2. And they want you to go from 2 to 1 for y. But that's not a typo. I make all these typos sometimes. You're the best for correcting me. There's no typo up here. I'll erase this part. They want this revolved about which axis? X-axis. I'm thinking again. I want to just think of some curve. I'll make my little image. I had some curve. I had to go from what? Some y value 1 to some y value 2. But if I'm going around the x-axis, maybe something like this. What's my radius again? Is it y or x? That y. I'm making that little y there. So that would be my radius. Man, a large that. I can't read that.
So you have to solve for y in the equation?
Good question, Armando. This is going to be your option in terms of how to set it up. We'll take the easiest route. I think what's kind of, if you're wondering, like the textbook usually gives it away though. They use y values. Do you see that? It's getting revolved about the x-axis. But by them giving us y values here, they're suggesting you might find it real easy to do it with the dy. So I'm going to use this, just because it's almost like this is a suggestion to me. And the other suggestion is how x equals, right? Everything's in terms of y. But when the key is, we still got to know what's this radius, so we don't get confused. It's going around this x-axis. This radius here. 2 pi r, there's a disk, or a circle. I should call it a circle because the disk would get filled in. We're just doing the surface area. But that circle just has a radius of y, right? So I'm thinking, okay, this is going to be integral of 2 pi y ds. So I just want to start there. You agree I haven't messed up? It's going to be surface area 2 pi y ds.
So every time it's around the x-axis will always be the radius of y.
That's right. Always. There you go. And hopefully kind of like, in terms of memorization, I would forget this like tomorrow. I have to really either make a mental image of this in my head or draw it. So I can really look to go, what is that radius? So I think there's one of them, but I'm summing a bunch of these to get that entire surface area along that length of that curve, you know, that arc. And I think, oh yeah, the ds is the arc length.
Thank you.
You bet. So it's always, in answer to this question, it's always a y there. But now you have an option. When you do all this, Connor's use this one or this one. I know, and he says use the bottom, the heads up is like, well, look what they gave us. Here's y values. And they wrote this expression of the curve as x equals this. So, I agree with Connor, and I'm thinking, let's go from y equals 2 to y equals 1. 2 pi letter y, and what am I putting here? This square root of 1 plus dx dy squared dy. And I don't think that derivative is going to be too bad. I don't think it's going to be too bad. This is interesting too, why I wanted to do this problem after the last one. Remember last problem I substitute x cubed here? I don't put like this there or anything. This just stays what letter? What? It's just going to stay a y because it's dy. This is fine. We just got to find that. The whole idea is everything's got to be in terms of dy. Right? Alright, well what is dx dy? Have you ever done that before? Have you ever taken a derivative of x with respect to y? I'm sure you know how to do it. Differentiate x with respect to the letter y. 3/2 times 1/3 is 1/2. And decrease this power by 1. Y squared plus 2, decrease it by 1. And then chain rule. Multiply the chain. What's the derivative of the portion in the parentheses? So when I do want to point out, some of you might be going, where'd that come from? That's the chain. Right, for chain rule. And I'm going to put that here, and then don't forget, we're going to square it. We're going to square this dude. Take that, jam it there, square it. But before I square it, don't the 2's cancel? So what is this? That's just y times a what? Square root of y squared plus 2? Now, if you forgot to square it, this would look like one ugly integral. So make sure we square this thing when we put it in here. There I go again. The integral. From 1 to 2, you can put the 2 pi out here. Keep that letter y there. I want to see that y. Square root of 1 plus, what's this squared? Y squared is, and my favorite part, what happens when you square a radical? Turns into a parentheses. Isn't that cool? But look, this problem is being assigned to us in the textbook in a section where it says find the exact value. That means you and I can figure this out some way. We don't have to pull out the calculator and do the definite interval. So far so good? Yeah. Let's see how to deal with this. Because Kate, right now, I'm not even sure, like, is this going to be a use of? I think we should start by just distributing this. And then maybe as we go along, we'll see something. Okay? But when we set it up properly, we put dx dy, we squared it. What if I distribute that? What do you get?
Y to the 4th plus 2y squared.
Ooh. Y to the 4th plus 2y squared, and you still have this plus 1. 1. And I'm going to write it in that same habit I've been taught my whole life, highest power to lowest power, right? So this becomes, inside the radical, y to the 4th plus 2y squared plus just a dy. Kate, this isn't a use of, because look at the power difference. Y to the 4th versus y to the 1st. There's got to be something else here. So no use of, this isn't a trig substitution. No way. It's not integration by parts, is it? And it's not partial fractions, but Armando nailed it. He says it's none of this. It's old school just factoring. You can factor that, can't you? Perfect, yeah. I'm going to factor this. He hits this by factoring. Armando, where'd he go? He thinks of this as y squared plus 1 times a y squared plus 1. He factored that expression. And when you get two of them, What's the square root of that? So good eye. I didn't see it at first. Maybe you didn't see it at first here. It looked messy. But once we got it all distributed, you're like, oh, I can extract this. So that's the integral from y to 2 of, well, I'll write it again. Look what you have. Y plus 1 squared. So now you can just write it as what?
Remember, I showed you y square plus 1 square.
Oh, y squared plus 1. Yeah, thank you. This just becomes a y squared plus 1? Just one of them? No use subs needed, just distribute. What's that distribute?
Y cubed plus y.
Q plus y. Alright. Y to the 4th over 4. Y to the 2 over 2. From 2 to the 1. Alright, what's 16 over 4? 4 over 2 minus 1/4 plus a half. All right, what's 6 minus 3/4?
5 and a fourth.
Is that 5 1/4?
Yeah.
And you said don't forget the and a 2 pi. Put it right out here. And she goes, don't forget about that 2 pi. 2 pi, 2 pi. Okay, thank you. 2 pi all this. 2 pi times 5 and a 4th. My answer is 2 pi surface area. 2 pi multiplied by, this is just 5 and a 4th, which is that 25 and a 4th? No, 21 over 4th as a fraction, which can be reduced to what?
21 over 2 pi.
21 pi root cube. And there we go, we hit the exact. That'd be hidden though if you hit it with the calculator because of the pi. So if you ran a definite integral on that thing. But hey, just factor out the pi and run the integral without that. You'll be able to see it too as well. Cool. Any questions on this? All right. Everyone, great job with this stuff. What I want to do is just leave time at the end. Go over any questions. People have questions about the test, work the problem again. I want to make sure, I always want to leave that time for that one-on-one. Sound cool? So if you don't have any questions, have a great day.